Hello guys, welcome back. This is the second video of STM32 programming with C++ language. In this video I'm going to show you how to create a new project in C++ and how to enable a LED with C++. So first we open the shell and we should create a new project. We go to project, new project, and select the path. And the name of the file, LED, select the board, and SEMSYS core device startup. That's it. And our project was created. Here we need to add a C++ file and we call it main.cpp C++. Add, and we need a header file, and the name of the header would be led.h. Alright, here we should include std.int.h because we are going to use integer type in our project, so we need this type of library. Alright, we should go to books and we need reference manual as well as data sheet. Alright, in the data sheet we should go to boundary address, and this is the table which provides all the address for our buses and peripherals. As you can see, HP3, HP2, HP1, etc. Okay, let me put some comment here. Imagine we want to enable the LED which is connected to pin 5 and the port is A. Okay, pin 5 port A. So we should go and find the address of port A because in C++ we are working with addresses, and this is the table. So let me AHP1, let me find the GPIOA. So GPIOA is a part of AHP1 and the address starts from this to this. So we need this address. Let's copy it. This is our GPIOB address. And let me put it here. And GPIOA. Alright, we have found GPIOA address. And we have also learned GPIOA is connected to AHP1. Let me check it. Yes. And now we should go to reference manual. Here GPIO, register, mode register. We want this address. This is the address of mode register, so we copy it. Let's put it here. Mode register would be this. As you already know, I should go and find the output data register, which is ODR. I need this address as well because I'm going to make my pins as an output. If I wanted to make it as an input, I should save IDR. So Or ODR would be this address. But there is one more. If you have already watched my register series, you understand we need to enable the clock for port A. So we should go to RCC, register base, and AHP1 because GPIOA is connected to AHP1. And here is the address of AHP1. But in order to access the AHP1, we should provide the address of RCC plus AHP and plus this address in order to access RCC AHP1 enable register. And do not be worried, I will explain it later. So AHP1 enable register would be this plus RCC plus AHP1. Alright, this is for clock. So it's time to create a class. So you are familiar with the class. I want to make it public. So let me write it first, then I will explain it. And here we should provide a name for our class. So here I create a new name for uint32. The new name would be port type. So in my code, whenever I want to mention this, I simply say port type. I just rename it. Here as well, instead of using uint32, I just say b value. By this piece of code, I just rename this. Alright. And this is port value and this is the bit value. And now I should create a constructor. I name it LED. You haven't learned the constructor, so do not be worried. I will explain it. And I will create another video for it, so do not be worried. My port type would be V. This is B. Port P. Bval B. Here also I need a private. Port Bval. Okay, you already know what's private it is because I don't want outside this class anyone use it. But if the member are public, they can be used in the other side of the class as well. Alright, let me explain this constructor. And whenever I create an object for this class, my constructor, which is LED, will be called automatically. And it requires two values. One of them is port. It could be port A, B, C. And another one would be bit value, which is 1, 2, 3. In my case, it would be GPIO A. pin 5. And I have created port and v value in a private member because if I change this, if anyone change it, my constructor will be behave abnormally. And here I assign the p as a port, so this means port, and v as a v value, which is b. All right, and let's continue. In the constructor, I need to first disable the bit value. Alright, I will explain it in other videos. It's a little bit challenging, so do not worry. Just understand that in order to enable the LED first or turn it off, first I should disable it. So here is the interesting part. I'm going to create a register. In a C language, the register are already created for us, but here we should create it manually. So let's create it. RCC AHP1 enable register. We said in order to get access to AHP1 enable register, we should provide these. One of them is AHP. As we said, our AHP1 is equal to GPIOA, so we need this plus and the offset value of AHP. All right, and RCC. Where can I find RCC? Let's go to datasheet and let's find RCC. It says this is the value. So let me copy it. So these are equal, so let me clear it. Add this to this, it would be this number, and add this number to this would be the address of AHP1 enable register, and that's very straightforward. But then there is something we should add. So here I tell the compiler that whenever I write rccahp1 enable register, you should go to this address. And remember that this is volatile. And this address could be changed unexpectedly. So this is not a valid value. It can be changed during my code, which is why I provide volatile. And this is the unsigned integer. Okay. And let's define another one. And next one would be GPIOA mode register. So GPIO mode register would be GPIOA plus mode register. Since it's 0, it would be the only GPIOA. That's it. And as you can see, it's really straightforward. If you have watched my C series, which I worked with register, and next one would be GPIO A ODR. So ODR would be GPIO A plus this offset, which is 14. And alright, we have created our register. Now let's go to our constructor. So we first disable the pin. Now we should make it as an output because I'm going to enable LED. So I have already provided the code and I will explain it. So if I want to explain it in an easier way, I could say that I created a variable and this is a port type which is UNT32, and whenever the user enter the port which is here, you should minus it from this number which is our ODR, so we get the mode register. As you can see, the difference between mode register and output get register is 40, so we should minus it. Here I receive the mode register, then I put 1 in the pin that the user entered. This is a little bit difficult, but you will get the hang of it when you program it yourself, and I will explain in another video. So let me just explain the second code. And let's go to GPIO, register, mode. As you can see, all the pin has 2 space, so we should shift 1 and times the v value to 2. So that's how you enable the pin. So do not be worried, this is your first video and you will learn how to do it. So our constructor was created successfully. Now we need a function to toggle the LED. We call it toggle. Here we need this, and it should be like this. And as you remember, I disabled it here, so I use the same code, but now I should enable it. This is how toggling works. Alright. And next function would be a delay. So it's a for loop. I equals to 0. I should be integer. So we have created our delay and toggle. There's still one thing to go. Let's go to our header. Let's include stdin.h. So if you know what namespace is, good for you. If you don't know, here's the explanation. When we have several class and objects with the same name, we create a namespace to avoid conflict in their name. A namespace is like a box. So I create a box, I put a name for it, let's say red. Alright. I create another box. In that box, namespace, called red. My second box has several objects in it. GPIOA. GPIO pin 5. And this is my GPIOA. So here I created a box, I called red. In that box I create another box and I put these two in it, so the name will not be conflict together with other classes. So here it should be this one. Let's include LED package, and in the main function we should provide std. Alright, we have done all of them. It's time to create our main project. We need the main, here with the while loop, alright. First we should enable the clock for port A. And 0. And let's go to the datasheet again. Reference manual. Let's go to RCC register, HB1. In HB1, if you want to enable the clock for port A, you should go to bit 0 and put the 1 in it, as we did here. 1 in 0 in order to enable the port A. Alright. Now we create an object which is LED. We name it LED number 5. Our first box was red. The second box was green. First I want to choose the port, which is A. Now I should do the same for it, for port pins. Now I create an object for it in the while loop. I want LED 5 to toggle. I also need my LED 5 some delay, and that's it. And let's build it. Okay, we have one warning. It's important. It says we should put a new line here. Okay, no error, no warning. Let's do it on the board. Before that, let's go to the debug section. This is my clock. Installing behavior. think that's it. Okay, load it. Under receipt. Load again. Okay, it was loaded successfully. Let's go to debug section. In the debug section, we should go to Peripherals, System Viewer, GPIO, GPIO-A. Here you can see all the register of GPIO-A. I need ODR. This is all the pins. So let's run it. As you can see, pin 5 is toggling. If I connect any LED to this pin, my LED will toggle as well, which means our code works successfully. And programming STM32 with C++ language is a lot to take, but do not be worried, I will explain all of them again, and you have a lot to learn. So stay with me. If you have any question, write them down in the comment section below and I will answer them ASAP. Thank you for watching. Bye.